Hi guys, my name is Stephanie Alexander. Today I'm going to be giving you a crash course into the Fibonacci sequence. The Fibonacci sequence was created by Leonardo Pisano, who was an Italian mathematician in the year 1202. So he created the Fibonacci sequence doing a thought experiment with rabbits. His thought experiment was as follows. Given optimal conditions, that means no rabbits getting sick and no rabbits dying and every pair of rabbits being able to breed, how many pairs of rabbits would he have at the end of a year? So at the end of this 1 year, he got 243 pairs of rabbits. But at the end of the first month, he had 1 pair of rabbits. And at the end of the second month, he had 2 pairs, and then 3 pairs, and then 5 pairs. And then it kept going on, and he created the Fibonacci sequence. So the Fibonacci sequence is you take the first number, add it to the second number, and you get the third number. Take the second number, add it to the third number, you get the fourth number. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and it keeps going on into infinity. That's a lot of numbers to list. Okay? And so the Fibonacci sequence correlates with the golden number. The golden number is phi, and the golden number is 1.618034. So to get the golden number out of the Fibonacci sequence, you take the ratios of the pairs of numbers that correlate with each other. So here we have some examples. If we take 2 and we divide it into 1, we get 2. If we take 8 and we divide it into 5, we get 1.6. So the higher you get with the numbers that you're dividing, the closer it gets to the golden ratio. Here we can see 144 divided by 89. We get 1.617978. Now, if you round this, it's 1.618, which is the exact same as the golden ratio if you round it. So over here, since the Fibonacci sequence goes on forever, it can be rather hard finding the number that you want to find in the Fibonacci sequence. And so Jacques-Philippe Marie Binet, he developed a formula for finding any number in the Fibonacci sequence. So the formula is f of n equals phi to the nth power minus negative phi to the negative nth power, all of that divided by the square root of 5. It seems rather daunting at first, but the formula actually helps a lot. So we're given n is the number in the sequence that you want to find, and phi is 1 plus the square root of 5 divided by 2. Now all you do is you substitute. So you get f of n equals 1 divided by the square root of 5. Then in parentheses, 1 plus the square root of 5 divided by 2 to the nth power minus 1 minus the square root of 5 divided by 2 to the nth power. And all of this will give you an answer that correlates with the Fibonacci sequence. So if you want to find the 8th Fibonacci number, you can list all your numbers out and you can count. 1, 2, 3, 4, 5, 6, 7, 8. And then you see that the 8th Fibonacci number is actually 21. But to prevent you from having to do that, you can just put everything into your formula here. So you put 8 everywhere you see an n, and that's the only substitution that you're doing. So you get f of 8 equals 1 divided by the square root of 5. Then in parentheses, 1 plus the square root of 5 divided by 2 to the 8th power, minus 1 minus the square root of 5 divided by 2 to the 8th power. All of that equals 21, which we just found was the 8th Fibonacci number. So it correlates directly with it. So you can go higher and higher. So if you wanted to find the 20th Fibonacci number, which is not listed up here, then you would just substitute 20 in for all your 8s. And you get the 20th Fibonacci number, 6,765. 20 of these numbers would be very hard and very daunting to actually list out, because you would need to list them like this to make sure that you were actually doing it right. A great practical use of the Fibonacci sequence is when you're converting miles to kilometers and kilometers to miles. There's a direct correlation between a lot of these numbers with the Fibonacci sequence. So as we can see, 1 mile equals 1.609344 kilometers. Now this is already related to the golden number. As you can see, they're very close to each other. So if you wanted to find how many kilometers were in 13 miles, you would just take 13 and times it by 1.609344. You get 21. 21 comes directly after 13. So if you wanted to find kilometers to miles, 1 kilometer equals 0.621371 miles. So then if you wanted to see how many miles were in 13 kilometers, you take 13 and you times it by 0.621371. You get 8. 8 is directly before 13. So when converting from kilometers to miles, the answer should be the number directly before the original. Our original was 13, so when we converted, see how many miles were in kilometers, we got that number. And so whenever we wanted to see how many kilometers were in miles, we got the number directly after it. So if you did the same thing with 21, you should get the numbers that surround it. And the same thing with 34, you should get the numbers that surround it. So some other practical applications that the Fibonacci sequence is used in is the Pascal triangle, continued fractions, art and architecture, music, and fractals. And that's just a very little bit of listings. The Fibonacci sequence is found in many different things. The thing that surprises me the most about the Fibonacci sequence is how prominent it is in our world. And the fact that it took someone almost 600 years to figure out that Pisano was actually onto something with this Fibonacci sequence. I hope you've enjoyed my video. Thanks for watching.